to 9 months because it varies a lot from school to school. They have vacation periods and a lot of different things. So we decided we have to teach the teachers as they are running their classes. So we invented this method where the teachers explore different topics, which is the B in my slide. And as they explore different topics, they teach the class to the students. And it's very challenging the first year you make this thing, because you don't know what comes next. It's like you're reading this novel as a teacher, right? And you don't know the result of the novel, but then you're telling the story to your kids in the afternoons, and the next morning you're reading the novel again, right? But I can tell you, this method really works. This is kind of like agile. It's totally an agile implementation with sprints and, you know. And it ends with a technology fair, because we removed exams from the picture, and then kids come and show the results to other kids. And we make these fairs across different countries. So this one is in Catalonia, and it was in Barcelona this spring here. Barcelona, we've made 5 years this project already. And actually this week we're starting this project whole Spain-wide. So the whole Spain is going to have 220 schools new running this, plus 300 from other years repeating. And this is what you see. You see 4,500 kids coming to a museum, completely hyped, because they're going to show the stuff to other kids. I can tell you the level of energy you feel when you see these kids is, you know, unbearable. And you see some places that repeat, like the bubble blowing machine. I've seen it for 3 years in a row, in different installments. You know, but that's part of the learning process. At some point, innovation kind of fades away, and the only thing you see is kids that are actually learning stuff. So the project stopped being new, or completely new, but that's not the most important part. As kids are working with something more like a socially concerned, like how to renovate or renew water and build water cycles. There's a lot of Star Wars going on. Well, yeah, I get emotional, so I will not. Oh, self-made drones are great. Also very dangerous, but they're great. So in 5 years, we reached 1,700 schools, 40,000 students, and you will say, but David, this is not too much. You know, we've seen numbers in the previous lectures like, oh my God, was playing with 1 billion people. Well, the thing is that this is people teaching people, and this is how much you can do. And what we're trying to do is build a rhizomatic network where we teach teachers that teach other teachers. I mean, that way we slowly expand until we cover a whole nation, and we will have a whole nation. We'll move to the next nation and slowly build a network of people that understands technology and they can use it in teaching. But at the same time, we realize that there is a different level of teaching, which is university, where Arduino was used, but not too much, because it's too easy. You know? How many of you graduated in the last 5 years? Not that many. Where are your young junior developers people? Should be coming to conferences. Anyway, I don't know how many university teachers told me that Arduino is too easy, that we don't want to teach it at school. And I was like, what? So we said, let's make something really freaking complicated. So let's go out and discuss with MathWorks, which is the company that makes this beautiful software that is used at every single engineering school. It is not open source though, but we have to deal with it. And we decided to build a kit that contains 3 projects that are really challenging for engineering students. So they can challenge each other, right, and compete and see who makes something best. Here you see Julia building this motorcycle. And this is a motorcycle that runs on 2 wheels and has an inertia wheel that will compensate for the leaning angle. The news in here is that you don't program this with C code, you program this with Simulink. So you write your control algorithm in blocks, and then you upload it to your board. And since you're using a board, which is one of these maker boards that has Wi-Fi and Bluetooth, you can send the data in real time back to the computer, and you can read what the robot is doing. And you could eventually implement an intelligence back in the computer to add intelligence to your robot. You can prototype a real thing, moving around, controlling stuff in the real world, and add as much intelligence as you want to. So, from the series of bad cameramen but great engineers, I present the self-balancing motorcycle. This is one of the guys from MathWorks showing off. And his friend should go to a media class. I love these moments when the camera actually goes completely out of vision. And there you go. And then it's balancing for some seconds, and then it says, oh, no more, and falls. So we published this. In the motorcycle project, we published this. We gave, so you get the idea, the content you have to produce to get a person from nothing to a moving motorcycle is the equivalent to a 500